Hello student, in our previous lecture we discussed about the lens maker's equation as well as refraction due to the single curved surface. Now today we discuss about the numericals from these two topics. Let's start. The first numerical from this textbook is on page number 187, example number, question number 3. From that question number 3, there is a 6th numerical is based on this topic. Let's start. The first, a convex lens is held some distance above a 6 centimeter. Above a 6 centimeter. That means the first of all we write given. In that given state, we write it is at 6 centimeter. What will be at 6 centimeter? We say that a convex lens is held some distance above a 6 centimeter long pencil. It is held above a 6 centimeter long pencil. Produces its image of same size. That means we discuss that the object and image is of the same size. On shifting the lens by distance equal to the focal length, equal to its focal length, it produces the same size. It produces the image of the same size as it is earlier. Determine its size. Determine the size. Now here we first of all write for a convex lens, it is given that the image is same size unchanged after shifting the lens to the distance equal to the focal length given. That means that here we write u is equal to minus f upon 2, where u is the object distance, f is the focal length of the lens, and by that it is shifted by object distance should be u is equal to minus f upon 2. Here we write that h1 is equal to 6 centimeter. That is the size. It will be equal to 6 centimeter. Here it is also given that both the images are of the same size. That is v1 is equal to v2. By using the formula 1 upon f is equal to, here this one is a given. Now we use the formula 1 upon f is equal to 1 upon v plus 1 upon u. 1 upon f is equal to 1 upon v plus 1 upon u. This is the formula for the thin lens. Now instead of this, we write here minus sign and substitute the values from this equation. Now we say that 1 upon f is equal to 1 upon v. 1 upon f is equal to 1 upon v minus, instead of u, we substitute 1 upon minus f upon 2. This value we substitute of this u. In the next step, we write like this: 1 upon f is equal to 1 upon v. This minus becomes plus. This 2 is on the opposite side, 2 upon f. On the next step, here we write like this: 1 upon f minus, this plus sign becomes minus on the other side, 2 upon f is equal to 1 upon v. By solving this, 1 minus 2 upon f, that means becomes 1 upon f is equal to 1 upon v. By comparing this, we say that v is equal to minus f. That v is equal to minus f. This is the image. Now we determine the magnification. That magnification, that m is equal to, we use the formula for magnification, m is equal to minus v is equal to minus v upon u, that is equal to h2 upon h1, or we say that h2 upon h1. We use this formula. Now instead of this, we substitute first of all the values. V is equal to, we say minus f. V is equal to minus F. U is equal to, it is given that minus F upon 2. U is equal to minus F upon 2. Therefore, we magnify that image. Therefore, we say that M is equal to, this minus minus becomes plus and this FF will get cancelled. M is equal to magnification, M is equal to 2. Now we determine the value of this H2. We have to determine that H2 is equal to question mark. That here we place like this. M is equal to H2 upon H1. M is equal to H2 upon H1. Therefore, we say that this 2 is equal to H2 upon H1. H1 is given to you, that is 6 centimeter. Therefore, H2 is equal to 2 into 6 by cross multiplying, which is equal to H2 is equal to 12 centimeter. Therefore, in the answer, last step we write like this. What will be asked in the question? Here, determine the size. The size of the image formed will be, we write last step, the size of the image formed will be 12 centimeter. This is our final answer. It is asked to us. Now I will repeat again whole example. Here in the example it is given that a convex lens is held at 6 centimeter above a 6 at some distance of 6 centimeter pencil. That is, here we say that the height of the pencil will be equal to 6 centimeter. Then next one, it produces its image of the same size. That means the first image of that will be of the same size. Therefore, we say that V1 is equal to V2. On shifting the lens by a distance equal to the focal length, equal to its focal length. That means here we write U is equal to minus F by 2. Here we have to determine its H2 will be equal to, that image will be of the same size. Here we say that determine the image of the size. Determine the image size. We use the formula 1 upon F is equal to 1 upon V minus 1 upon U. Now we got the answer 1 upon F is equal to 1 upon V minus becomes plus 2 upon F. By solving this, we get V is equal to minus F. Now we determine the value of this H2. To determine the value of this H2, we have required the magnification. We use the formula magnification is equal to minus V upon U. The similar formula will be another magnification is equal to size of image to the size of object. Now first of all we determine the value of this n. Magnification m is equal to minus f upon 2. This minus will get cancelled or becomes plus. This f will get cancelled and this denominator 2 will becomes numerator at this position. Therefore, we got magnification is equal to 2. In the next step, we substitute that magnification is 2, size of image and size of object. Here we will say that H2 is the size of image and H1 is the size of object. Therefore, H2 upon 6, we transfer this on this side, we got H2 is equal to 12 centimeter. Therefore, the size of the image formed will be of equal to 12 centimeter. This is the one numerical from your text which is unsolved on page number 187. Okay. Now we take the another example. Now we take the another example where from your text it is example number 8. Example number 8. On page number 187. These two examples are based on this topic that we discussed yesterday or in the previous lecture. Let's see. A point object is kept 10 centimeter away from the double convex lens. A 10 centimeter away from a double convex lens of refractive index 1.5. That means here an object distance. First of all, we write a given. Object distance is denoted by the symbol u. Object distance is denoted by the symbol u, where u is equal to minus 10 centimeter. That because object is placed toward the left hand side, therefore we write here minus sign. Here u is equal to minus 10 centimeter and of refractive index 1.5. Refractive index having symbol n, which is equal to 1.5. On the next step, we write and radius of curvature of 10 centimeter and 8 centimeter. That is, first curvature surface has radius, that is, we write here symbol r1 is equal to 10 centimeter and r2 is equal to 8 centimeter. r2 is equal to 8 centimeter. Now determine the location of the final image considering paraxial rays only. Now we use the lens maker's formula by using from lens maker's formula. We will write like this. Lens maker's formula 1 upon f is equal to n minus 1 into 1 upon r1 minus 1 upon r2. We discussed this formula that lens maker's formula 1 upon f is equal into bracket 1 upon n minus 1 into bracket 1 upon r1 minus 1 upon r2. Now we substitute the values of all these values. N is equal to 1.5 minus 1 into 1 upon r1. r1 means 10 minus 1 upon r2. R2 is a second lens. Here, when we use this curvature, here object is placed on the left hand side. Therefore, we take here minus sign. This is the first curve surface which having the positive radius. And this second curve surface which is on the left side. According to the sign convention, we take this r as a minus. Therefore, here minus sign comes. We write here minus 8. Now we solve this. 1.5 minus 1, that becomes 0.5 into bracket. Here 1 by 10 plus 1 upon 8. Here we solve this 0.5 into bracket. Here 40. We take LCM as 80 upon 8 plus 10, which is equal to 0.5 into 80 divided by 80. Now solve this. This 5 by 10 means 5 upon 0.5 means 5 by 10. We solve this 90 upon 800. We got the answer 9 by 80. 9 by 80 will be equal to 1 upon f is equal to 9 by 80. Therefore, f is equal to 80 upon 9 centimeter. Now here at this condition, we determine first of all the focal length of this lens. Now we determine the formula by using the formula 1 upon f is equal to. Now we use the formula 1 upon f is equal to 1 upon v minus 1 upon u. Now substitute in this equation. We got the value of v. What we have to determine in this equation? Determine the location of this image. That means in this equation we have to determine v. We have to determine the v. Therefore we say that in this equation 1 upon f means 80 upon 9, which is equal to 1 upon v minus 1 upon u. Value of u is equal to minus 10. Value of u is equal to minus 10. By solving this, like this, here 9 upon 80 is equal to 1 upon v plus 1 by 10. Now shift towards on the another side. 9 by 80 minus 1 by 10, which is equal to 1 upon v. Here we multiply by 8. Therefore 9 minus 8, that is 9 minus 8, that is 1 upon 80 is equal to 1 upon V. Therefore, V is equal to 80 centimeter. V is equal to 80 centimeter. Therefore, in the last step, we write the final location of the image will be 80 centimeter from the lens. In the last step, we write the answer like this. The final image will be at 80 centimeter from the lens. Here we have asked like this, say the location of this image. Here we say that the location of the image, the location of the final image will be at 80 centimeter from the lens. Okay, this is about the numericals which are based on the lens maker's equation as well as the refraction due to the single curved surface. Okay, thank you.